Hello everyone, I'm Sanskar Datta from 5th SEM doing CSE Chanakya. So today we are going to learn about relational model concepts and relational model constraints. So here we go. So introduction to the relational model. The relational model is a conceptual framework used to organize and structure data in databases. It defines how data can be stored, organized and manipulated in a way that can maintain the integrity and consistency of the data. The relational model uses a tabular structure with rows and columns to represent entities and their attributes, establishing relationships between them. This so it basically says that a relational model it's basically a table so which contains a set of rows and columns, and it gives the relationship between them. So this model has been widely adopted due to its simplicity and flexibility, making it a fundamental concept in the field of database management. So what are entities and attributes? Entities in the relational model, an entity is a distinct object or a concept such as person, place, thing or event about which data can be stored. So for example, like Ramesh phone number is something, the phone number is an entity. So each entity is represented as a table in the database with each row in the table corresponding to a specific instance of the entity. Attributes are the property characteristics of an entity. They are represented as columns in the entities table and define the specific data that can be stored for instance of the entity. So key and relationships. A primary key uniquely identifies each record as a table in a table and ensures that each row is distinct. It is a crucial concept for establishing the integrity and uniqueness of the data. Foreign key. Foreign key is a field in a table that links to the primary key of another table, establishing connections between the two tables. It plays a vital role in defining relationships and enforcing referential integrity. So the cardinality and participation constraints. One to one, many to many, one to many. There are three. So for one to one is each record in first table is related to exactly one record in the second table, and one to many, each record in the first table can be related to one or more records in the second table. Many to many, each record in the first table can be related to one or more records in the second table, and vice versa. Normalization. The definition of normalization that it is the process of organizing data in a database efficiently, eliminating redundancy and dependency. It aims to minimize data and inconsistencies and ensure that each piece of data is stored in the most logical place. The benefits of normalization is that it reduces data duplication, saves storage space, and enhances data integrity, leading to more reliable and efficient databases. Drawbacks is excessive normalization can lead to complex query structures and may result in reduced performance in certain database operation. So first, normal form. The atomic value of one NF, which can be said as one NF as well. So each column in a table contains atomic values, ensuring that each piece of data is indivisible and avoids multi-valued attributes. So no repeating groups. One NF prohibits the inclusion of repeating groups within the same table, requiring the creation of separate tables to handle such cases. So second normal form 2NF. It addresses partial dependency, ensuring that each non-key attribute in a table is fully dependent on the entire primary key. Eliminating redundancy. It eliminates redundancy by breaking down tables into smaller ones, reducing the chances of data inconsistency. Third normal form 3NF, non-transitive dependencies. It removes non removes it removes them, then ensuring that no column is transitively dependent on the primary key. The benefits and the limitations of relational model is, so the benefit is the relational model offers more simplicity, data integrity, and flexibility, making it suitable for various applications such as banking banking systems, inventory management, and transactions. Limitations are including challenges. It includes potential performance issues with complex queries, which we've learned earlier in normalization. So difficulty in handling hierarchical data and the need for rigorous planning and design. So basically, these are the applications what you've seen in what you've seen in this benefits. So the applications are the business systems. The relational model is widely used in business systems for managing customer data, sales records, inventory, and financial transactions. Healthcare informatics. It is employed in healthcare informatics to store patient records, medical history, and treatment details in a structured and secure manner. E-commerce platforms. E-commerce platforms utilize the relational model for managing product catalogs, customer orders, and transaction processing. So now we're going to learn about the relational model constraints. So we have learned about the relational model. So now about the constraints we'll learn. So the relational model in database management is built on the concept of data entry. We've learned this. So it uses various constraints to define and enforce rules on the relationships and attributes within the database. These constraints ensure that the data remains accurate and reliable, providing a solid foundation for organizational data management and decision making. So, primary key constraint, what we have learned, like this is the more detailed explanations for this. So, uniqueness. The primary key constraint ensures that each record within the table is uniquely identifiable. It acts as a unique identifier for each row, enabling efficient data retrieval and eliminating duplicate records. Data integrity. By defining a primary key, the database prevents the insertion of null or duplicate values, maintaining the integrity of the data and supporting accurate relationships between tables. Relationships. It facilitates the establishment of relationships between tables, acting as a reference point for related records in other tables. Foreign key constraint. So same as what we have learned. So the foreign key constraint establishes a link between two tables, denoting a relationship between the referenced key in the child table and the primary key in the parent table. So data consistency. It ensures that the values in the foreign key column match the values in the primary key column, maintaining data consistency and referential integrity across tables. The operations. When a foreign key is defined, operations like updates and deletions are restricted to preserve the integrity of the associated data. So unique constraint. So the unique constraint ensures that the data in a column or a combination of columns are unique, prohibiting the insertion of duplicate data. Violations. When a unique constraint is violated, the database system rejects the insertion or modification of data, maintaining the integrity of the database. Performance. It enhances performance by allowing data to enforce uniqueness directly, rather than relying on application logic to maintain uniqueness. So, check constraint. Data validation. The check constraint enables the database to validate the values entered into a table based on predefined conditions, ensuring data accuracy and consistency. Conditions. It allows the specific of check conditions for each row, significantly reducing the need for complex validation in application code. Flexibility. By defining custom check constraints, specific business rules and requirements can be enforced at the database level, offering flexibility in data validation. Not null constraint. So, data integrity. Not null constraint ensures that a column cannot contain null values, thereby maintaining the integrity and completeness of the data. It guides users in inputting essential information by mandating the presence of data in specific database columns. When querying the database, the not null constraint guarantees that the selected columns will always contain meaningful and usable data. So now we're learning about default constraint, the preset values. The default constraint allows the specification of data values for columns, ensuring that a valid value is present in the case the user input is absent. It offers convenience to users by automatically populating fields with predetermined values, reducing the need for manual data entry. By providing data consistent default values, it contributes to data consistency and standardization across the database. So what and all we have learned. So the relational model constraints are vital elements in ensuring the accuracy, integrity, and security of data within a database. Each constraint serves a specific purpose and collectively contributes to the reliability of the data and the effectiveness of database operations. Understanding and implementing these constraints is crucial for maintaining high quality data and robust database management systems. These are the things we learn about database concepts and constraints. So that is all. Thank you.